Hey everybody, how's it going? Hope you guys had an awesome weekend. Hopefully got outside a little bit. It was a little chilly, but I got some sunshine. Um, so yeah. Uh, anyway, hope you guys had a good weekend. Now, I did say we were going to have a quiz today. All right, I did say that. However, I know this virtual school is really difficult. I completely understand it's difficult on me, difficult on you. Um, and I was reading your feedback, and I'm gonna work on some things, okay? And I'm trying my best. I want you guys to succeed, and that's my main goal. I know this fourth quarter's nothing what we expected it to be, but I still want you guys to succeed, okay? So we're actually not going to do a quiz today, okay? No quiz. Um, but yeah, I got amazing feedback. And so since we're not doing a quiz, we're actually going to move on. We're going to move on to gas laws. Now, we've been going at a pretty quick pace throughout this each week. So today's a big assignment. Thursday's not too big of an assignment. I mean, today's not a big assignment, but we're gonna take it back a notch, and that's okay. I want you guys to stay focused, stay energized. All right, fair enough. Does that sound good? Sounds good to me. All right. Now, I'm going to introduce gas laws, and then I'm going to introduce the assignment that goes along with today. Okay. So first, here we are, gas laws. Okay. Now, we all know what gases are. We know like oxygen is gas. We know hydrogen, helium, they're all gases. Okay. So now we're going to be talking about something known as ideal gases. Now, you don't have to write this down. Okay. I'm just introducing it to you. Okay. Ideal gases are imaginary gases. It's like, what? All right. That perfectly fit all the assumptions of the kinetic molecular theory. All right. So gas consists of tiny particles. All right. Collisions between gas particles and between particles in the walls of the container are elastic. Elastic means stretchy. So you kind of bounce like a bouncy ball. You know what I'm saying? All right. And no kinetic energy is lost in the bounce. Okay. Now, gas particles are constant and rapid in motion. All right. There's no attraction, etc. All right. So that's kind of what gas laws are. We all know, hopefully we kind of knew what gas laws were. Okay. And the main topics of gas laws are, here's the assignment. The main properties of gas laws are pressure, volume, temperature. Those three are the main things we are going to focus on. Okay. So what you guys are going to do today is, here's the assignment, right? You're looking at it. All right. Learning goal. To access, you're going to click on this. So control, click on that. Oh, I did something. There we go. Okay. All right. What's the next step say? Drag your mouse to the simulations tab and click chemistry. Okay, I did that. Scroll down and click gas properties simulation. Gas properties right here. Okay, did that. Click on the play button to run the program. Well, there it is. Run the program. And last, select ideal. And that's how you get to the website, okay? Now, this define pressure, you can just Google that right here where it says define pressure, Google that. All right, make a prediction as to what will happen to a certain gas in these conditions. All right, so if temperature doesn't change. If I increase the pressure, what's going to happen to my volume if I increase pressure? You're guessing. This is just a guess. All right. So if I increase pressure, I'm going to say my volume's going to decrease. So I'm going to bold that. Like I said, just a guess. I don't know. All right. If I increase volume, I think my pressure might decrease again if I increase volume. I don't know. Like I said, where all of these problems right here is just make a guess, define pressure, okay? And etc. Let's say I'm going to guess increase here. I'm going to guess increase. And I'm going to guess one of both here. All right. Now, this is where you simulate it, okay? And I'm going to go over the first one for you guys, all right? So the first one says, if I have a constant temperature, so I'm going to go back to the website, okay? And I'm going to put temperature in Celsius, okay? So I'm going to add some particles. Let's add some heavy particles. There we are. All right, so we got our particles. That's our gas right there. That's all floating around. How cool is that looking? All right, so after adding the particles, let's see. I need a constant temperature. All right, so hold constant up on the top right here. I'm gonna hold constant the temperature, okay? And then it says, what will happen, since my temperature is constant, what will happen if I increase the pressure? All right, what will happen to the volume if I increase the pressure? That's why the X is over here. All right, so I'm going to increase the pressure. How you do that is you pump this. Wow, that's going crazy. That's so cool. What's happening to the volume? Well, the volume's getting more compact. It's getting smaller, right? The volume, the space between the particles is getting a lot smaller. So the volume, I'm going to put an X, goes down. The volume goes down. That's all you're doing. You're marking X marks the spot right there. All right, the volume goes down. All right, let's do the second one. All right, just walk through another one. Constant temperature again. So I'm just going to reset this. All right, so I'm going to add some particles. Constant temperature again. Now, what's it say this time? What happens on an increase in volume? So if you look here where my pressure's fluctuating around 6, would you say? Yeah, I'd say 6. All right. What happens if you increase volume? Now, how you do that is you extend your arm out. Increase volume. Oh, what happened to my pressure up here? It went down. Okay. So my pressure went down. X marks the spot, and then you move on. Okay. How you increase and decrease temperature is by, well, let's do volume, is add heat. You add fire to it, and that's how you add heat, okay? Or you can cool it. Ice cools, fire heats, okay? And that's how you answer those questions, okay? Now, number 3, what happens to the actual molecules when the temperature increase, okay? Just look at the molecules and how might that affect the pressure, okay? And then the last question says, what is the relationship between volume and temperature, okay? Directly means as one increases, the other increases, okay? So let's look, volume and temperature, or actually, since we did pressure and volume, let's do that. Pressure, volume, when pressure increased, the volume decreased. So when the pressure increased, the volume decreased. That means, right here, that means it's inverse. So your answer for this last question is inverse, okay? And that's how you solve these problems, okay? Not too bad, not too bad. Yeah, okay. So that's what we're doing today, okay? That's what we're doing today. Guys, I hope you have an awesome week. If you have any questions, shoot me an email or get on my Google Meet each day. But it would be helpful to, like watch this video while you're doing your homework or try it out. Yeah, shoot me an email. Thursday's assignment won't be as rigorous. It will be very short assignment, like last week, actually. Pretty similar to last week. Okay, so anyway, guys, you guys are awesome. Hang in there. We're doing a good job. Hopefully we get to see you guys soon. All right, we'll talk to you later.